All right, this is the last lesson in this unit, and we're going to be doing logarithmic regression. So we've done exponential regression for 2 days, and now we're going to do logarithmic regression. So this is where your information is going to be using a logarithmic pattern. So logarithmic growth or logarithmic decay. Okay, and what this means is you're going to be selecting a different regression model. Okay. And we're going to be using logarithmic regression. So if you go on your graphing calculators and you hit Stat and go over to Calc and scroll down, you'll see that there's a whole bunch of regressions. There's linear regression, there's quadratic regression, cubic regression, quartic regression, linear regression. Again, I got that one twice, okay? And LNREG, and that's the one we're going to be using today. So natural logarithm regression. And right below it is that exponential regression that we had been using the last couple of days. So today we're doing logarithmic regression. And these models are best for when populations or things are growing very quickly, okay? So this works the same way. We're still gonna put L1 and L2 in our calculators. We just have to select a different regression tab. So if you go to Stat, and then Edit, and in L1, you're going to put 8, and then 14, 22, 40, 48, and 54. And then in L2, we're going to go 4, 18, 48, 60, 71, and 73. Okay, so we've programmed our calculator with our two lists. Now we're going to do select logarithmic regression. So Stat, and then Calc. Scroll down to LNREG, and here we go again. All right, and we do want to store this as y1 just like before, and hit Enter. And so we get this equation here. All right, now we're going to round both to the nearest integer, a and b. So y is equal to negative 74 plus 37 ln x, okay? Don't be tempted to do like the y equals a bx. That's exponential growth, okay? So we got to use this. And how do I know to put it in this order? Well, do you see in the first part of what we calculated? So the top line of the stuff that's pink currently, it says y equals a plus b ln x, and then the a and b values are immediately below it. So that's where the negative 74 comes from, and you'll see that it's just by itself, plus b multiplied by ln x. And ln x means logarithmic, okay? Graph the equation using your calculator between 0 and 100. So go to Window, change your x minimum to 0, and your x max to 100. And our y max, well, it looks like we're getting up to like 73 when it's 54. So our y max should probably be like, let's double that. Let's go to, actually let's not double it, let's go to 100 for y max, okay? And hit graph. And hopefully yours shows up like the blue line. I'm just gonna delete something quickly here. So it should look like that, okay? Graphically determine the height of the plant to the nearest inch after 38 days. So that's a x value. So if you go to second calc value, when x is 38 and then hit enter, it's going to pop to there where your y value there is 60.96. So after 61, it's going to be 61 inches tall. Okay. The corn will develop tassels when it reaches a height of 52 inches. So that's another time value. So y2 we're going to set equal to 52. Hit graph again, and you'll see that line at 52. The red line goes straight across at 52. It's always 52. So then we're going to calculate the intersect. So second calc intersect. And on mine I have to go to the left boundary. Yours will say first line and then second line. Hit enter. And then where it says second line, you hit enter again. And then on mine, it's good to go. it's going to give me an x value of 29.86. So that's after 30th day. Okay. And then the last one, we need to figure out when did it germinate. So that's at the beginning. So if you scroll down to where y is 0, it's going to be around 7 days there. I don't know if you can see that, where this blue line, the blue dot's getting close to 0. Okay, so we can also set y2 equal to 0. Whoops, y2 equal to 0. Hit graph and then hit the intersect again. And you'll see that you get a x value of 7.3. So y2 equal to 0, calc the intersect, and we get an x value equal to 7.3. So that's approximately 7 days. Okay. Which is the logarithmic equation? Well, this is linear, because it's kind of straight. This is exponential decay. This is also linear. This is our logarithmic growth. So number 4 is logarithmic. Okay, during prolonged colds in northern latitudes, thick ice will grow on lakes. A particular lake in Ladysmith, Wisconsin has its ice thickness measured every day after the temperature fell below 0. Data is shown below. So days, that's kind of like a time value, so that's L1, and L2 is going to be the ice thickness. So stat, edit, and we need to put in our new information. So 6, 9, 14, 20, 27, 32, and 55. And then we get 0.8, 1.7, 3.5, 4, 5.2, 5.5, and 7.2. And we've clearly missed something because the two sets of data don't line up. And I'll see there, it should be 20 on its own, and then 27 on its own, 32 on its own, and 55. There we go. Now we have the same amount of data. So get back to your main menu, hit stat, calc. Now I'm going to have to do it twice, but you can do it once. Oh, hey, look at that. And we're going to store this as a regression equation. So vars function y1, and then hit enter, and we get this new equation. So our a value is, maybe I'll do it like this time. So y is equal to a plus b ln x. So we're going to replace a and b with our values there. So y is equal to negative 4.5 plus 2.9 multiplied by ln x. Okay, there's our equation. Graph this equation from 0 to 80. So our window settings, let's change that to 80. And graphically determine the thickness of the ice 49 days after freezing. So calc value when x is equal to 49. Value x is equal to 49. Oh, my y scale is crazy off. So you'll notice that the y max here is like 7.2, but my y scale has it going up to like 100, which is way too much. So let's go to like 10. Let's see what that looks like. That's much better. All right, so again, let's go to second calc value when x is equal to 49, and you get a y value of 6.82. So approximately 7 inches. Okay. And graphically determine to the nearest day the number of days below freezing necessary for the ice to reach a thickness of 7.8 inches. Well, this is a y value. So let's make y2 equal to 7.8. And then we're going to graph the intersection. Okay, so then second calc, intersect. And on mine it says left boundary, right boundary. On yours it should just say first line, second line, hit enter, enter. And we get an x value equal to 68.53 days. So after 68.5 days, you're good to go. Okay, and that is it.